Hi friends, in this lecture, let us see the construction of Turing machine for one's complement of binary number. The problem is to construct Turing machine for finding one's complement of binary number. Let us understand the one's complement of binary number is obtained by inverting zeros into ones and ones into zeros. For example, if the input is 10100, the ones complement of this binary number is 01011. Let us find the solution for this problem. Before getting into the solution, listen to Turing machine part 1 lecture so that you can easily understand this concept. Link given in the description. The first step is start from the left. Second one, if the existing bit is 0, convert 0 to 1, or if the existing bit is 1, convert 1 to 0. Repeat this step 2 until a blank symbol is found. If blank is found, stop the process. Let us see the construction of Turing machine for finding one's complement of binary number. Q0 is the initial state. In this initial state, the transition is if you find 1 in the tape, convert to 0 and move the head to the right. If you find 0 in the tape, convert to 1 and move the head to the right. That means we are repeating the same steps again and again until a blank symbol is found. So if you find a blank symbol, you keep it as it is and move right and reach the Q1. Q1 is the final state of this Turing machine. Let us see the transition table for this Turing machine. The format of the transition table is current state and the possible input symbols. So here the input may be 1, 0 or blank. So this arrow indicates that Q0 is the initial state. So if you find a 1, so what will happen? Again you will come back to Q0 state, but this 1 will be changed to 0 and move the tape head to right. Like that, if you find a 0, again you reach the Q0 state, but 0 will be converted to 1 and move the tape head to the right. If you find a blank symbol, reach the Q1 state from Q0 and keep the blank as it is and move the tape head right. Q1 is the final state of this Turing machine and it is denoted using this star symbol. Let us see another way to represent Turing machine, which is called as instantaneous description. This description is a configuration of the moves over some input string. So this representation allows us to trace the tape content and determines whether the Turing machine will stop at the final state or not. We use turnstile notations to denote the configuration. The turnstile notation, that is this symbol, represents a single step transition in automata theory. That means we take the particular input and we trace the moves for the particular sample in the Turing machine and whether it ends in the final state or not. Let us consider the sample input 1011. These symbols are available on the tape. Q0 is the initial state. When Q0 finds this one symbol, this 1 will be converted to 0 and again it come back to Q0 state. In the next step, when Q0 finds a 0, this 0 will be converted to 1, again it comes back to Q0 state. In the next step, when Q0 finds a 1, this 1 will be converted to 0, again it comes back to Q0 state. The next step, when the Q0 finds a 1 symbol, this 1 will be converted to 0. Again it come back to Q0 symbol. And finally, when Q0 finds a blank symbol, it goes to final state Q1. Now we have obtained the 1's complement of 1011. The final answer is 0100, and we have used only two states Q0 and Q1 for this particular Turing machine.